Again, welcome back to my channel. Today we are going to do the applications of calculus questions. For example, we are having this one which says determine the points of the curve on the curve this where the gradient of the tangent of this curve is equal to -1, which means the gradient of the tangent of this curve is equal to -1, and we know that the gradient of the curve itself is the same as the gradient of its tangent at the point of intersection. So on that note, we really want to know what is the gradient of the tangent at a specific value. Now, to find the gradient of this tangent is to write the tangent itself, the curve itself, then therefore find the derivative of this curve. Before that, let's make it to be in a differentiable form, just like that, so that our y prime becomes -4 then over x squared. So this is the derivative of this curve now. Now, they are saying the derivative or the gradient of this tangent. The gradient of the tangent is the same as the gradient of the curve, remember? So which means if the gradient of the tangent of this curve is -1, which means we know that this is the gradient of the tangent on its own, then we have to equate it to -1. So we have -1 is equal to this gradient that we have identified there. Now, cross multiplication, we have negative this is equal to negative that, then therefore we have x squared is equal to 4, then therefore we have these values of x is equal to 2 and x is equal to -2. So these are the values of x where the gradient of the curve and also the gradient of the curve of the tangent is -1. So it's when x is equal to 2 and x is equal to -2. But when they say calculate the points, which means we really need to find the y-axis as well. Then the y-axis will be found when we substituting by, in the place of x, you substitute by -2 to get -2. Then in the place of x, you can also substitute by 2 to get 2. So that means when x is -2, y is -2. Then when x is 2, then y is also equal to 2. So these are the points where the gradient of the tangent of this curve is -1. It's where x is equal to -2 is to 2, then therefore the other coordinate is 2 is to 2. So these are the points that are required. The idea is to first find the gradient of the curve by deriving the curve, then therefore say equator no -1 because siqalelwe that the gradient of the tangent of the curve is -1, but we know that the gradient of the tangent is also equal to the gradient of the curve at the specific point. So that is why we have equated the gradient of the curve by -1 to find the x values. So that's what's number 1 for applying what a calculus to determine some parameters. Then taking us to the second question, we are having a function g, which is given by ax squared plus b over x, that has a minimum value at x is equal to 4. Minimum value at x is equal to 4. Once they say minimum value, this is the specific turning point, which is the minimum turning point. X is equal to 4 there, and the function at x is equal to 4 is 96, which means the function itself now is 96 at x is equal to 4. Then therefore we are required to calculate the value of a and b. Now you will remember that at the minimum, which is at the turning point, we know that the gradient is equal to 0. So we can just apply that information first, that at x is equal to 0, at x is equal to 4, the gradient of this function is equal to 0 because this x is equal to 4 is at the minimum, which means this is the what, the x coordinate of the turning point. So now to find the turning point, we know that at the turning point the gradient of the function or the derivative of the function is equal to 0. So it is wise for us to derive now this function over there. Finding the derivative of this, you will find g prime of x being equal to 2ax, then blah, it's going to be negative b over x squared. So this is the derivative of this function. So we know that at x is equal to 4, this derivative is equal to 0. So we can just substitute by 0 in the place of g prime, then therefore in the place of x, then we are going to put 4, of course, then therefore then we have minus b over 4, which is going to be 16 in this case. So we can just now say 8 times 16, then it's 128. So we have 0 is equal to 128a minus b. So we are having this one, if we can multiply by 16 throughout, so we have this small equation. So having a and b in this equation, we can just call it equation number 1. Then the second one, it's whereby we use this point, because now it's clear that this point is the actual turning point, that we have x is equal to 4, then y is equal to 96. So actually at the turning point, at this minimum turning point, we have 4 as and what, and 96. So we just need to now use these coordinates. Now having this one, we're gonna say 96 in the place of g, which is equal to a, in the place of x we put 4, but this 4 is going to be squared, remember, then plus b over 4. Good. So this is what we have now. Then therefore if we can just multiply by 4, 96 times 4 is equal to 384, which is equal to then 8 times 4, which is 16 times 4 is 64. So we have 64a then plus b, just to make it linear. Then on that note, we can just come here, say our b is equal to 128a. Then the place of b we can just put 128a. So that gives us 64a. Then the place of b we say plus 128a. Then what are we having? Then 64 plus 128 is going to give us 192a. Then we have 384. Then our a becomes then we have 384, then divided by 192, then our a becomes just 2. Then coming back to b, in the place of a we put 2, then we have 128 times 2, then the answer becomes b is equal to 256. So this is what we have now. We have figured out that b is 256 when a is equal to 2. So it's only when this x is what is the minimum value of this graph, and the function has this point, which is the turning point, of course. Then we are looking for a and b, then a and b is that. So you can just write your equation if it's required. Then your a is 2, then x squared, then plus b, your b is just 256, then over x. So we can just have that. So that when we can, if we can just try to put 4 here, and check if we're really gonna get 96. Then we have 2 times 4 squared, then plus 256, 256, then divided by 4. Yes, you get 96. This is equal to 96. So which means our A and B are correct. Now coming to the next one. The next one, it says calculate the value of A and B if f at x is which is equal to this, has the tangent at x is equal to -1, which is defined by this equation. So this is the tangent of the curve at x is equal to -1. So we are to determine the value of A and the value of B when this information is given. So what do you need to remember? You need to remember that we are having this point that you can substitute in the place of f at x. So our f at x is defined by this graph. Then if we can actually put the idea is to know that we are having this point. We can find the point of contact, because of course if we can substitute by -1 here, we'll be having two unknowns. But if we can use this equation of the tangent and substitute by -1, we're really going to get the point of contact where this tangent and this curve intersect. So we just need to use our tangent to substitute the value of x. So we have y, y is equal to -7 and then -1 plus 3, just to find what is the corresponding y value. So we have 7 plus 3, which is just 10. Now these are the coordinates that we have, that we call them point of contact. Now we can now take this point of contact and use it on our function. Then in the place of x, I can put 10, whereas in the place of x I can just put -1, then all squared, then plus, then b times -1, then plus 5. Then after having this one, you can see that it can be simplified to be just a minus b plus 5. That makes a minus b to be just equal to 5. Yeah, so we can call this one, and that's just an equation 1. Then for the equation number 2, we just need to remember that there is a gradient given there, that the gradient of this function is equal to the gradient of this tangent at x is equal to -1. So we just need now to remember that the f at x has to be derived, so that we have 2 ax then plus b, then this is what we have. So this is the derivative. So the derivative is equal to -7, which is the gradient is equal to -7. So we are having -7 here, which is equal to 2a, and we know that this gradient is -7, right, at x is equal to -1. So this is what we have. So on that note, we can just summarize to have -2a then plus b is equal to -7. So this is just equation number 2. So we can now try to use our two equations to solve simultaneously. So we know that to this equation, a is equal to 5 plus b. Then in the place of a here in this equation, we can just have -7 is equal to -2 times a, and our a is 5 plus b, then plus b, then what are we having? We have -10 minus 2b plus b is equal to 7, negative 7. Then therefore 10 minus 7 is equal to 10 minus 7 is equal to 3. Then is equal to, then we have negative b, remember. Then therefore b is equal to negative 3. So if b is negative 3, then your a from here, your a is going to be equal to 5 minus 3, which is just going to be 2. So we are now done. The value of a is 2 and the value of b is negative 3. So the idea is to use both of these things. Remember, we were given the equation of the tangent, which is having the gradient, which is negative 7. And we know that if this is the equation of the tangent, the gradients of these two equations, they are going to be equal at the point of contact, which is this one. So that is why now we have used the gradient of the tangent, because the equation, the tangent is given, you just take the coefficient of x as the gradient of the tangent. Let's take this the next one. The next one says determine the gradient of the tangent of the graph of f, which is equal to that at x is equal to negative 1. So this seems to be similar. But the gradient of the tangent, now we're looking for the gradient of the tangent. But what we know that the gradient of the function is equal to the gradient of the tangent at the point of contact, which means now at x is equal to negative 1. So the idea is to find the gradient of this curve, which is going to be negative 9x squared, then minus 4. So this is the gradient of this function. But at x is equal to negative 1, we can actually find the actual gradient at x is equal to negative 1. So we have negative 9 is to, you have negative 1 whole squared minus 4. Minus 4, then this is equal to, so we have minus 9 minus 4, which is minus 13. So we have minus 13. This is the gradient of the function at x equal to negative 1. That is also equal to the gradient of what? Of the tangent. The gradient of the tangent is also equal to negative 13, because we know that at the point of intersection, the gradient of equations of, or the gradient of those functions, has to be equal to each other. So we are done with this one. Done. We just need to equate the gradients of the gradient of the function and the gradient of the tangent. Let's come to this one. Now we are to draw, I believe this is the last one. We are to draw we are given the function f at x, which is defined by that. Then to draw the possible sketch of y is equal to f prime. So we are going to draw the gradient of this function, the gradient of this function. If a, b, and c are all negative real numbers, they are all negative real numbers. So we know that for them to be negative, the idea is to first find the function of f prime. So f prime is going to be the derivative of that, which is defined as 3ax squared, then plus 2bx, then plus c. So this is the function that we are drawing the sketch of. Now, if a is positive, then you will remember that this f prime is just a parabola, né? So if a is positive, which means the coefficient of x squared is going to be positive, we know that the shape of the graph is going to concave upwards, just because of this information. So the graph is going to, this graph that you are going to draw is going to concave upwards. First thing is obtained. The second one, b must be all of them must be negative, or b, okay, to a must be negative. Okay, for a to be negative, the shape of the graph, it has to concave downwards. Good. So it has to concave downwards. -1 problem. A is negative, a must be less than 0, then therefore the graph is concaving downwards. Then therefore b is negative as well. Then when b is negative, then therefore that means the turning point is going to be on the left side of y-axis. For the Cartesian plane like that, we know that the shape of the graph is like this, but at the end of the day, the turning point has to be on the left side of y-axis, because b is negative, which is the coefficient of x of the middle term is negative. Then therefore the graph or the turning point has shifted slightly to the left from y-axis. Now coming to c, if c is negative, that means it has to cut the y-axis just below ex values, ex intercept. So c must be there, then the turning point must be on the left side of y-axis, then the shape must be concaving downwards because a is negative. So this is just a rough sketch of this graph, where you need to show these perimeters, not necessarily to draw or to have ex intercept and stuff like that, just to analyze the effect of a, the effect of b, and the effect of c. So this is f prime, which is the derivative of f at x. So on that note, let me close it for now. We shall meet on the next video, but for now, please enjoy the stray, and you can just comment on the comment section. Keep the channel busy, and I'll try by all means to also interact with your queries and your cries, or whatever that you really want me to help you with. I will, yeah, I'm looking forward to help you in anything. So thank you guys, see you right in the next video.